Hello students, welcome to section 5-8 quadratic inequalities. Graphing quadratic inequalities. To graph a quadratic inequality in two variables, use the following steps. First, graph the related quadratic equation y equals ax squared plus bx plus c. We'll use a dashed line or curve for less than or greater than, and a solid line or curve for less than or equal to or greater than or equal to. Second, we'll test a point inside the parabola. If it satisfies the inequality, we'll shade the region inside the parabola. Otherwise, shade the region outside of the parabola. We'll also take a look and see how when we graph parabolas, and if the inequality is less than versus greater than, or less than or equal to versus greater than or equal to, we could devise a plan wherein maybe we don't necessarily have to use a test point. We could just kind of go through and see, okay, if the parabola opens up and it's a greater than, for example, we'll shade above or inside the parabola. And if in fact it opens up and it's a less than inequality, or less than or equal to for that matter, we'll shade below or outside the parabola. So again, test points, although they work, it turns out you can do another kind of set of steps to get the shaded region as you should. So for example, we're going to graph the inequality y greater than x squared plus 6x plus 7. The directions or the answer key does indicate first graph the equation y equals x squared plus 6x plus 7. So that's what this parabola entails. Okay. It also says by completing the square, you get the vertex form of the equation y equals x plus 3 quantity squared minus 2. So the vertex is -3 comma -2. And yes, that is the vertex, as you can take a look here at the graph. It also says to make a table of values around x equals -3 and graph. The curve is dashed, okay, because of the inequality being a greater than. And then they describe using test points. Now before I continue, I do want to discuss how the graph actually does take shape, again thanks to completing the square. So I've already completed the square off to the right here for you, which if you recall, again, me rewriting the problem first as an equals sign or with an equal sign as opposed to an inequality. This is called the related quadratic equation. I've pulled out the 7, okay, and then we perform the steps of which just on this particular quantity, x squared plus 6x plus this perfect square, which I end up getting by doing these 3 steps, of course. This is the blank value that we set up, as well as this blank value, by doing again what? B as 6, or identifying it as 6, then doing b over 2, dividing 6 by 2, of course, is 3, and then b divided by 2 squared, which is 9. So in the blank spot, to complete the square fully, we get obviously x squared plus 6x plus 9. Outside here we get -9, because again we're trying to balance, so to speak, but because we're on the same side of the equation, this sign is always going to be a minus sign. 7 minus 9 in the next step, of course, is -2, and this perfect square trinomial nicely enough factors as such. You can rewrite it as x plus 3 quantity squared. This is the vertex form as we discussed earlier in prior sections. And then, of course, we know that the vertex is -3 comma -2. And again, as the directions or answer key describe here, the vertex is -3, -2. Then we pick points like -4 and -2. Plugging them into the original problem or function, you end up with -1 for both y's. If I were to graph on the calculator, which I do also recommend you take a look at, okay, so I typed in advance x squared plus 6x plus 7. And yes, the graph should take shape, not surprisingly, very much like what you see here. The graphing calculator can actually shade for you, but you actually have to tell it based upon the symbol here to the left. You have to turn that into, instead of this slash mark, turn it into a triangle below or a triangle above. We'll go ahead and skip that shading process, because you actually have to tell the calculator how you're going to be shading. And not only that, you're not able to see a dashed curve. The graph, again, though, is enough for us to make that connection. And then, yes, you could use test points as they describe, but let's take it a little bit of a different route here. If, in fact, you were to look at the inequality again, y is greater than the function. Remember that when we did this with lines, Greater than implies above. So we're actually going to shade above and inside the parabola. Okay. Just to make a finishing touch comment here, I do want you to maybe take a look at the table just to confirm that in fact the other two x, y values in question were -4, -1, and -2, -1. Of course, the vertex was -3, -2, as we described earlier. Completing the square, of course, yields this end result. So let's take a look. The problems that follow, I am perfectly fine with you completing the square on your own. For the sake of time, I'm going to go ahead and ask that you type this into your graphing calculators and just kind of take a look and see how it unfolds from there. But again, completing the square is still great practice for you to kind of see again how the vertex form unfolds. So let's take a look. For the next question, I did not purposefully, I did not have the XY axis there because I actually have the graph ready once I type this in. We have x squared minus 6x. Actually, pardon, minus 8x, so I'm going to change it from minus 6 to minus 8. And then lastly, of course, I'll just insert 1 as such. So okay, we take a look at this x squared minus 8x plus 17 graph. Here's your parabola. Okay, now the inequality is greater than. So instead of using a test point, I just want you to consider again, because we have a parabola that opens up and because we're thinking about values above or greater than the parabola, we're going to shade technically inside and above the parabola. Not only that, it should be a dashed curve as opposed to a solid because, again, the inequality is simply, well, greater than. So let's see how this unfolds. When you do graph using the calculator and or completing the square, I do want you to come up with 3 points minimally to get your graph across. You can, in fact, also discover that if you hit second trace, option number 3, you can find the minimum or vertex of the parabola. Why don't I do that just to kind of shore up any questions that may exist with regards to maybe the points that you'll pick, including the vertex, but surrounding the vertex particularly. So let's go ahead and surround the vertex, left bound, right bound. Again, I'm using the minimum feature, and I end up with this decimal, so 4, 1. So if you were in fact to pick then 3 and 5, let's say, for your XY table, 3 and 5 both have Y values of 2. And of course the vertex is at 4, 1. We already said that it was going to be shaded above, and there you have it, dashed and shaded above with the vertex of 4, 1 and 2 additional points like I indicated earlier. Let's take a look. I think number 2 is another great question to take a look at. I might have you try one of these on your own. Let's go ahead and type it in again. Again, I encourage you to complete the square later on your own just for practice and to see if in fact your vertex form matches the graph. So here's your equation. We have y equals x squared plus 6x plus 4. Okay, and we'll go ahead and do the same basic thing where we're just going to graph. And yes, you could find the vertex again. Keep in mind, as well as finding the vertex, 2 additional points should be what you discover and decipher. It appears to be -1, -2, -3, comma. I'll hit my second graph feature. In fact, it looks to be -3, -5. -3, -5, and 2 additional points, -4, -4, and -2, -4. That would be good in terms of graphing. Again, minimally those 3, let's say. Because it's a less than or equal to inequality, I'm going to be shading below the graph or the parabola. So function values below, in this case down and outside of the parabola. As well, keep in mind, because it is a less than or equal to, technically we also want a solid parabola as opposed to a dashed. So the graph should end up taking shape as such, with the shading included. I encourage you to take a look at number 4 on your own, and also graph on your own. And if you do use the completing the square approach to find the vertex form, putting it all together should yield this final graph. But please take a look and double check that it does in fact open down. On your graphing calculator it is dashed and you're shading down and inside, noting those maybe 3 points that you can kind of see here with the vertex, what appears to be a 2, -2, and then 2 additional points. But try that on your own just to prove, in fact, that you're right. Moving on, we're going to go ahead and continue where solving quadratic inequalities in one variable can be solved graphically or algebraically. We've already discussed completing the square. That will be something that you can do as you see here as an algebraic approach. You could also use the quadratic formula. And if in fact it is a factorable quadratic, that should be maybe your best option if you see that to be the case. Graphically speaking, we've already discussed how that's going to take shape, but there's more nuance to really both approaches. As I described, maybe not using test points, graphing and shading below and above, but maybe not really even drawing the full parabola, which we're about to take a look at in the next example. And they do show the full parabola, but I'm going to do a little bit more here. I've got some work off to the side, and I have some work up here that I'm going to kind of uncover in a moment. Solve the inequality, x squared minus x minus 6 less than or equal to 0. Okay. First, find the roots of the related equation, x squared minus x minus 6 equals 0. The equation factors as such. So you have x minus 3 and x plus 2, and that equals 0. Your two roots should be 3 and -2, right? If you set the factor of x minus 3 equal to 0 as well as x plus 2, you get 3 and -2. Turns out that -2 and 3 you can draw on the number line. Now I'm going to go ahead and uncover and kind of portray how that could also take shape accordingly. But I'm also going to uncover a few more things. So in the inequality originally, you do have a less than or equal to 0, which indicates two things. First, it's going to require you to look for negative output values on your number line. And yes, this is the full graph of the parabola, but I also want us to take a look at the number line in context. Less than or equal to 0, again, we want negative outputs, but also we want a closed set of values, particularly two values in our set of analysis points. And speaking of which, here's the set of analysis points. We've got -2, -2. We've got 3 and 3. Without actually drawing the parabola, what you can do is you can make a number line. Now again, the number line represents essentially the x-axis. And what you go ahead and do from here, and I can go ahead and get my calculator going once more, you can take the values and essentially show you what I'm speaking to in terms of test points. It's not truly a test point per se, but it is in effect testing x's. If I store -3, which is less than -2, as x, and then I type in x squared minus x minus 6, if the value is positive, that is not going to be a part of my answer. If it's negative, it is, because remember, I want negative outputs. In fact, if you do that with -3 stored, you get positive outputs. Do the same thing with a number like 0. 0 doesn't even really need to be stored. You can store it if you'd like, but 0 is usually one of the easier values because when you store it, and then if you hit second enter a couple times, once and then twice, so pull back the original quadratic, hit enter, and you in fact get a negative output. So negative outputs, again, that's what we wanted. That tells you you are going to in fact shade in between these two or draw your number line accordingly. And then as far as the final value, we can go ahead and just assume that 4 won't work. You can plug it in on your calculator again, but in fact you'll see that it does not. So let me finish this problem by noting how the number line in fact then speaks to that interval notation as your final answer. Now off to the left, yet again, this is how the book kind of describes things. They graph the full parabola, and the answer in fact falls between -2 and 3, including both -2 and 3. So the interval notation takes shape as such. So from here on out, you are able to not only graph the full parabola, but you are also able to graph and look at the number line using this notation. I'm going to conclude the notes here, but I do want you to take a look at, and I will uncover 1, 3, 6, and 8 so that you can see fully how those respective number lines take shape. And you can, of course, also graph it on your calculator to confirm.